Okay, so for the next topic in my test prep series, I wanted to take a look at quadratics. That was chapter 2, section 1. We spent one day on it. It was kind of a big lecture, but it was a one singular day because it is a topic that you guys studied exclusively or pretty extensively back in Algebra 2 and Math 2. So let's go ahead and jump into that, and I have a few problems prepared. Let's kind of see how that plays out. So the first thing is back in Math 2, as well as Algebra 2, I know you extensively discussed how to graph problems like this. So the first thing I hope you would have realized that this particular problem had a vertex of -3, -5. So 1, 2, 3, 1, 2, 3, 4, 5. And from that place, I think most of our teachers taught the nice little 1, 3, 5 that is embedded within quadratics. And so if we went over 1 up 1, over 1 up 1, 2, 3, over 1 up 1, 2, 3, 4, 5, with that little piece of data, we have a pretty substantial amount of information that makes it pretty easy to make a nice graph. And I often don't make a big deal about it, but you should also be aware that the axis of symmetry always goes through the x component of that vertex. Now, in my second problem, what I did is I specifically decided to make it have a little more steepness to it. So it has a vertex of 1, 2 right here, but instead of using the 1, 3, 5 pattern in this case, it's going to use a pattern of 2, 6, and 10, because remember, numbers in front are vertical stretch factors. So using my 2, 6, 10 pattern, over 1 up 2, over 1 up 6, 6 right there. That's going to be like that. And again, oops, missed that value a little bit. Again, I have a nice little vertex of x equals 1, 2. So x equals 1 becomes my axis of symmetry. And finally, notice in this particular situation, we have a -3 stretch factor. So again, going to the vertex of +2, -1 right here. This one, again, the 1, 3, 5 pattern that we have, it's going to be right here. It's going to be -3 and -9 and -15. And I always write them down, even though often I can't even reach those values. 1, 2, 3. And then we had 9, 4, 5, 6, 7, 8, 9 just barely fit on this particular piece of graph paper. And we have our story, and yet again, we have it going through my axis of symmetry at x equals 2. Now, sometimes you could be asked to do the same idea, but what about if they said, here's the graph, and I would like you to come up with, if you can, the equation of what's sitting in that graph. So in my first question here, you're going to notice that I have a graph who has a vertex of -4, -3. So I know that my graph has a vertex of -4 and -3. So that was fairly simple. But then I just have to figure out what is the number sitting in front. So I'm going to look for my 1, 3, 5 pattern. And I notice in this one, if I go over 1 up 1, if I go over 1 up 3, it in fact holds, which means I could put a 1 there, but I don't have to. In other words, the graph that I got was simple x plus 4 squared minus 3. Now, of course, in the second question, you right away would realize, oh, well, it's definitely going to have some kind of a negative in there, isn't it? Because it is going down. I notice that it has a vertex of 3, -1, so that's going to be x, excuse me, that's going to be x minus 3, and a -1. And then again, I'm going to look for that 1, 3, 5 pattern, but I notice when I try to go over 1, it goes down 2. And then it goes over 1 and it goes down 6. So if the 1, 3, 5 pattern turned into -2, -6, -10, it pretty clearly is the equation y equals -2, x minus 3 squared minus 1. And last but not least, down here, I have another vertex at -1, -5. But I kind of messed with you a little bit here, because when I try to go over 1, and I go up, it doesn't go all the way up. It goes up a piece. And then when I go over 1, it went up another little bit. But what I notice is it looks like it might go up a half, and then it goes up 1.5. So in other words, it went up 1/2 here, it went up 3/2 here, and let's see, does it go up 5/2, or also known as 2.5 here? Over 1 up 1, 2.5. Oh, it does look like it does that. So it looks to me like we just have a stretch factor of 1/2. Now, the real reason for the video that I'm doing today is partially to remind you of that, but also then to talk about what happens when we actually don't get the form that we like. What happens when you hand somebody something in standard form? So it's not in vertex form. And of course, that's going to make it a lot harder to graph. And we had a few ways that we did that, but I'd rather have it in vertex form. So the process that I would love to see you do is called completing the square. Didn't give myself quite enough room in that hole. So what we did in class is I had you factor the 3 out of both of the x terms, and then we considered what value we would need to complete the square. So you took the 8 part right here, we cut it in half, we squared that. 8 cut in half is 4. 4 squared is 16. So it looks like I have now added 16. That now makes that a perfect square. But I've also made it incorrect because this number was not there, and I need to balance that. And 3 times 16 is actually 48. So I need to take 48 away so that I've added and subtracted 48 simultaneously, which now creates a nice completed square like this. And now I know that my parabola has a vertex of -4, -55, and my 1, 3, 5 pattern turned into 3, 9, and 15. So I'm going to put this problem up here for a moment, and I would like you to try this one on your own. So go ahead and try that on your own and hit pause, and I'll do the answer in a moment. So go ahead and pause your video, try it yourself. Okay, so if I factor the -2 out, I didn't mean this to have exactly the same number as the last problem with the 8. It could be any value. But if you take 8, cut it in half, and square it, just like before, it was 16. But what's different now is I have -32. So if I want to balance a -32, I need to add 32 so that I haven't actually changed my question. And now I'm pretty much ready to go. Remember, when we cut that 8 in half, we got 4. And I now have my full story. And that's the vertex you should have had, or vertex form. Last question in this particular video. Again, please feel free to pause as you go so you can think through what's happening in there. But sometimes we don't give you values that are quite so kind. And so students don't like it when they go to factor the 4 out of the 3, and you kind of can't, because 3 divided by 4 is just 3/4, and that's not very nice. So, but we can handle this, because what we're going to do is we're going to take this 3/4 right here, and we're going to cut it in half. And I'm just going to make a little note to myself right there that when I cut it in half, I got -3/8. But if I square -3/8, I get +9 over 64. Kind of a strange little number. And it turns out that 9/64 times 4 is actually 9/16, because the 4 goes into 64. And that usually does happen in problems like this where you could reduce them. So I've got a +9/16, so I'm going to subtract 9/16, and now I can write my final answer. And so it's not that this would be a fun problem to graph, because its vertex is at 3/8, comma, and unfortunately, if we took 7 and we subtract 9/16, that's not very nice. 7 minus 9/16 is kind of an ugly number. It's 103/16, and that's my vertex. Now, before I leave all of this, one of the things that I like to do myself if I'm taking a test is to make sure I haven't made any careless mistakes. So what I like to do is I'm just going to take problem number 2 right here, And I am going to try to type that in. I've got negative 2x squared minus 16x plus 5. Now, in terms of a window, I know the vertex is at negative 4 comma negative 37. So I need to let this thing go down quite a ways because it had a vertex at negative 37. So, I mean, maybe even negative 40 would be smarter as a minimum. Now, if I have done this problem correctly, when I rewrote this as negative 2, parentheses, x plus 4 squared, and then plus 37, I changed what the question looks like, but I should not have changed what it actually says. So if I hit graph, I should see exactly one graph because these should be right on top of each other. So let's see what happens. So here comes my first graph. I actually did that the wrong way, didn't I? I should have moved it to the high side and I went to the low side. But the interesting thing is it doesn't really matter. If I look at my table, you'll notice that the tables on both graphs match. No matter what values I pick, the graphs are the same, which tells me that my equations were the same. And so that's a nice way to confirm that you've actually done quality work. I hope that was helpful, and I'll see you again for the next video in a few moments. All right.